Statement execution count for the final exam. This is going to be a big deal, okay? Statement execution count for nested loops. So let's try to figure out what's going on. If I'm inside this square function, how many times does the assert call happen? Once. Same rules as it ever was. If you're outside the loops, it happens once. Unfortunately, in our function, that's the only one that's outside the loop. Now, how about this guy? Oh, you know, we never did this with a for loop before, so we're going to have to kind of incorporate that into our knowledge. All right? So when we're doing a for loop, we have to kind of use our understanding of how the for works. It's like this I gets 1 is outside the loop, right, before the loop begins. This I++ is inside the loop, and this is the test, right? So when we hit a for loop, we actually have 3 separate counts. This is going to be 3 counts at once. How many times does the let I get 1 happen? Once. Good. And I'll just separate them by semicolons, just like it is on the for loop. How many times does the I is less than or equal to n happen? Yeah, if we're talking about n total, is it n or n plus 1? N plus 1, because it's going to work for I starts off as 1, it goes to 2, 3, 4, 5, 6, blah, 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 all the way up to n. It has to fail on that n plus 1th time, so it's going to be n plus 1. Good. If that's the case, how many times does I++ execute? N times. Every time in the loop. The loop executes n times. Okay, now for the tougher part. Actually, the easier one is down here on line 23. I'm going to do that one next. How many times did the console log fire? Is that also n? You guys see that? It's just like the I++. Every time you get into the loop, console log executes. Now, let's do this line next. Process standard out. How many times does that execute? Okay, so check it out. This is inside the J loop. J goes from 1 up to n, right? So it's actually going to make this test n plus 1 times, right? But the stuff inside the loop should only happen n times, just like any other loop. So it's n times, right? But what else? We have the big circle and the little circle, right? Yeah. It's n times for the little circle, then the little circle moves here. Then it's n more times, then it moves here, n more times. Right? So everything inside the I loop is happening n times, right? Everything inside the J loop is happening n times. So everything inside the J loop is happening n times, n times. Yes, it is n squared times. I'm getting the sense that not everyone's on top of it here. You guys get why that is? Who's ready for Thanksgiving already? Well, at least you're honest. It's freaking Thursday. It's a full week. Never mind. It gets worse every year. Pretty soon it's gonna be like Halloween and people are gone. Anyway, so now we still got to do this one.
Wouldn't this be n plus 1 squared?
Well, okay, yeah, but there's three different things going on. Okay, so first of all, and that's wrong. but it's close. It's close. Okay, so the let J get 1. Once, it's going to happen once every time the J loop fires. Right? How many times do we get to line 20? Well, for the first time. Yeah. Everything inside the I loop happens n times. So we begin the J loop n times. So that is going to happen. Let J gets 1 is going to happen n times. Good. The easier one again is the J++, so let's do that. J++ happens every time we get inside the J loop. We know that's n times, but the J loop is running n times. So that's n squared, just the same logic as the process right. Okay, so this is the one I think you guys were trying to answer a minute ago. And we said n plus 1 squared, which is close but not quite.
Be n plus one squared.
Not n plus 1 squared, but okay.
Times n plus
Okay.
Last answer, n squared plus n.
That's correct.
Okay.
You're both correct. Because if you work yours out, it comes to that. But yes, so what it's going to be is, right, the test is going to succeed n times and it's going to fail 1 time. So you get your standard n plus 1. However, everything inside the I loop is executing n times. It can't be n plus 1 squared because, right, this one fails once, but when it fails, we're not going inside the loop. So you're doing this n plus 1 times, n times. So it's n times n plus 1. N times n plus 1, which I'll just note equals n squared plus n. Oh, so actually I'm not sure if you said the right thing. I can't remember. This is the right answer. What's on the screen is the right answer.
Later on.
Later on. Okay, cool. We're all good. Okay. Oh, I guess we're done. What's the total then? If I go down here, I can say my total is, let's see, I have an n squared here. I have another n squared and another n squared, so it looks like 3n squared plus all my n's. There's 1, 2, 3, 4, 5n. And then I got 1, 2, 3 ones. So 3n squared plus 5n plus 3.
Did you have 4 ones?
1, 2, 3. I have this fourth one, but when I multiply it out, that n multiplies by it, so I get an n.
Okay.
Yeah, that's why. So yeah, be careful not to double count this part. Okay, so I think if you remember when we did the single loop, we came up with things like 3n plus 3, and we said that was big O n. You guys remember the big O thing? Which just meant as n gets larger and larger, you know, as the size of your array or whatever got larger, then the amount of work it did got larger. In this case, we go above an n, right? It's not just 5n plus 3, it's 3n squared plus 5n plus 3. So the key to this is looking at the highest power of 2 in your statement execution count. In this case, it's an n squared. The multiplicative constants and the additive constants don't really mean much in the long run. So we're just going to say that this equals big O n squared. Right? Remember what big O meant was complexity, right? The order complexity. So if we come up with something that's 3n squared plus 5n plus 3, or we come up with something that's 20n squared plus 6n plus 27, basically they're the same speed. Okay? It's the n squared that dominates when n gets larger and larger. So in this case, it's not an array, but as we make our square bigger and bigger, the size of the square is what's really going to drive the thing, right? And it blows up. Right? If I was just doing like a linear search through an array, if my array got to 100 items, it took me 100 comparisons to find it. If it got up to 1,000 items, it took 1,000 comparisons. Here, if I have an array with 10 items, sorry, not an array, but a square, a 10 by 10 square, it's going to take 100 executions, or based upon 100. 3 times 100 plus 50 plus 3, right? 353. If I go up to 100, I get 100 squared, which is 10,000 different iterations. So it really grows more quickly, right? So this is much, much slower than just a standard loop, okay? So it's so takeaway, Nested loops are much, much slower than single loops. Okay? So why do them? Sometimes it's the only way you can do a problem. Right? So if you have to, you have. You can print a square like this up. Okay, let me give you one more challenge before we call it quits for the day. Same basic problem here, but what we're going to do, well, I guess I don't need to do that. Let's say we want to make something like this. Okay, and that's going to come off of triangle 4. Oh shoot, no, we don't want to do this. This is your homework problem.
Oh.
Let's do this one instead. This one's easier actually. Similar, but like this. All right, so if I say triangle 4, instead of printing a whole square, I'm going to print a right triangle where out of zeros, and it's just going to be 1 0 on the first row, 2 zeros on the second row, 3 zeros on the third row, etc. Okay, it's going to be quick because it's similar to the first problem. Okay, so let's zip through it here. We're going to say function triangle n. And we're going to say, well, look at this. I need to print n rows again, right? So that's going to be a for loop, and I'm just going to say for let I get 1, I is less than or equal to n, I plus plus. I should also assert here that n is greater than or equal to 0, as before. Okay, so it's just like the first one. But this time, when I print my row, the key difference is instead of each time it has 4 items, it has a different number each time, right? It has 1, and then it has 2, and then it has 3, and then it has 4. Still going to be a for loop, so we're going to say for let j get 1, j is less than or equal to something, j plus plus. Personally, I would love it if a programming language would let me do this, and like I could fill in the question mark question. But then I'd probably be out of a job. So, in the middle of this, we'll do process dot standard out dot write 0, a couple spaces, and after it, we'll do console.log for a new line. In fact, identical to the last program we wrote, except this guy here. Okay, so can you tell me how to fill in that blank? So good. Yes, so check it out. The first time through the I loop, we only want to go have a row of 1 0. When we're going through the I loop, the first time through, I is equal to 1. The second time through the loop, I comes up to 2. In that case, we want 2 zeros. When I goes up to 3, we want 3 zeros. When I goes up to 4, we want to have 4 zeros. So we want exactly I zeros each time. So instead of saying j is less than or equal to n, we can say j is less than or equal to I, which is changing dynamically. Okay? And now, if I say triangle 16, .js? No, it's still square. I put it in the same file. There it is. Okay, so we'll pick up with that on Monday. We can do the statement execution count for that. In all seriousness, we're going to be doing some nice theory for the next couple of lectures, so you should come.